Alright, so we still remember that this unit is full of just a little bit of different stuff. So remembering what each one is. Okay, number one is absolute value stuff. Okay, so the first question, I'm going to do some algebra. I'm going to get rid of the 7. Okay, algebra, I'm going to get rid of the 2. And now this is where I get rid of the absolute brackets by doing a split. Okay, so inside of those brackets I could have had an 8 or a negative 8 inside. So the inside could equal 8 or the inside could equal negative 8. Do you notice how I keep those brackets on until I make that split? Okay, so this one would be add 1, so 9 divided by 5. And this one, if you add 1, it's negative 7 over 5. Okay, next I'm going to algebraically get rid of the 10. Now what? Should I split it?
Yeah.
No.
No, you could.
There's no solution. What do we know? Absolutes can't be negative. Okay, when we're doing absolute graphs, what do the big 3 ideas? What's the absolute value of a positive number? What would you get if you did an absolute value of 8? 8. So what happened? You didn't do anything. What's the absolute value of a number 0? 0. It stays. What's the absolute value of a negative number, like the absolute value of negative 7? What does it do? Becomes positive 7. So those 3 ideas, put that onto the graph. So if it's positive or 0, you have to show me an overlap. It stays. Don't write nothing and assume that I think it's there. Show me overlap. And then those 2 pieces, you have to change that positively. So for instance, this was negative 1, now it's positive 1. Okay, did you notice how I have an arrow here because that has an arrow? I don't have an arrow there because that doesn't have an arrow there, right? So be careful with that kind of thing. Okay, next. What do we know about this function right here? What do we know? Parabola. What are our two major ideas? What's the 5 and there's a negative? What are the things those are doing? What happens when there's a negative in front, like that? The parabola is going like that. And what does this plus 5 do to this parabola? That'll be up 5. So give me a point there. Actually, I should probably be doing this lightly, because this isn't my graph yet, right? I should probably do this lightly. Can you go over 1, down 1? Over 2, down 4? Over 3, down 9? And draw a lightly shape, like lightly, because that's not my graph. I gotta still absolute this thing. So that's not my final answer. Okay, so I have the idea of what that looks like. Can we absolute that? So where it's positive or 0, and then when it's negative, we're going to reflect it. Let's see. Does that make sense? I kept it where it was above the at or above above the x-axis. I kept it. When it was below, I flipped it. Okay, so that's absolute. Reciprocal functions. So this one looks like this notation. I should remind you on this, you might see this means the absolute value of a function. This means the reciprocal of a function. What point, or how do you know when the point is going to be invariant and not move when you reciprocate it? So what number in math is the same number once you flip it around? 1. Because when you flip it, it's still 1. What other number? There's 2 numbers in math. What's another number that would do that? -1. Okay, and these are when I'm looking at heights. We're always looking at heights, analyzing the heights. Okay, so where do you see points that do not move? Heights of 1, heights of -1. Oh, and another one. Those 4 points do not move when I reciprocate it. Okay, what happens to the height of 0 when you do 1 over 0? Do we remember what happens with that? Mathematically, it's an undefined number. But how do we show that on a graph? Do you remember that crazy word? Remember it? It's something that probably was weird sounding to you. Asymptote? Okay, so wherever there's a height of 0, the new height is an undefined height. Okay, now I'm going to do each section, so I have 3 sections to analyze. On the right hand, what is going on in this zone? I would say this zone is getting closer to 0. So now I should do what? I should go away from 0. Okay, now I'm going to do the middle zone. So I'm looking at this point. It was the highest of the section, highest height of 3. The highest height is going to turn into the lowest height. So what is the lowest height now? 3 is going to go to 1/3. And then what do you do to connect those points? You're going to go upward and then away. Upward and away. Okay, now I'm going to look at this section right there where I have a highlighter. This section is getting closer to 0, so now I'm going to go away from 0. Okay, now I'm looking at this section right here. The arrow is saying your graph is going away from 0. So now you should do what? You should go closer to 0. Ooh, that creates something else now. What do you need on a graph when you're telling me you're going closer and closer and closer to something? Now you need an asymptote there now. As soon as a graph is going to go closer, closer, closer to something and not hit it, okay, solving this inequality. Okay, so first of all, I'm going to see where does it equal 0, and I'm going to do that by factoring. So 8 times 4 should work, right? I need a minus. Okay, I'm going to analyze what's going on. So I put the x values on a number line. At -4, y is exactly 0. At 8, y is exactly 0. Okay, let's test something. Anything over 8 you can put in. So I'm going to go with a 10. Okay, 10 subtract 8, positive. 10 plus 4 is positive. And if I multiply those two positives, I get a positive. Okay, I'm going to test something in between. Anybody have a really good x value to test in this zone? 0. FYI, -32. So, negative. Okay, you could have plugged it in and been like, oh, 0 minus 8, negative, 0 plus 4, positive, which makes negative. And I'm going to test -6 in this zone. So negative 6 minus 8, negative. Negative 6 plus 4, negative, which makes it positive. So please remember on your test, I might give you one that's a triple factor. So when you do your tests, make sure you're timesing 3 things together, positive, negative, positive, whatever. Okay, let's answer the question. Where am I above 0? So I'm above 0 in this zone, and I'm above 0 in this zone. So when I look at that as a domain, how do I write it as a domain? So from left, we're going from negative infinity up to negative 4 with what kind of bracket on this one? Soft, because why? I can't be equal to 0. If you hit that spot, you're 0. Union, so or this zone. So this zone is from 8 to infinity. As soon as you have an equal sign as part of that, this is a square. Okay, solve this system and then we'll graph it. Okay, when I put these together, what would you like me to do? We have elimination or substitution. Doesn't matter to me, you pick. I feel like this one would be easier with substitution. I'm going to substitute. So y equals that and y equals that. I'm going to replace the y into the other equation. Does that make sense? Okay, so there's my substitution. What kind of algebra strategy do you go with here? As soon as you see something that looks like this, what's your instinct? 0. You got to zero it out. Okay, we have x squareds and x's, so it's got to be a 0. So I'm going to minus 2x and minus a 1. So what does this side become? So x squared minus 2x, and I can put those units together, minus 3. Okay, now I think I can factor this. So 3 times 1 minus plus okay, this is not your answer. So if x equals 3, what is y going to be? Can you go tell me by plugging it into either one, whatever math looks better to you? I'm going to go with this one. What's 2 times 3? Got it? Plus 1. 7. Or you can write it like that, right? A coordinate, 3, 7. And the other solution, if x was negative 1, what do you get? Negative 1. Okay, so here's your two solutions. Okay, now let's graph this. Okay, first equation, parabola, -2. So -2, can you put a point there? Can you go up 1 over 1? Up 2, or sorry, over 2, up 4. And then 3 over 9 up. Okay, I did my 1, 1, 2, 4, 3, 9. Okay, second equation, when I graph it, what is it? Should be a line from grade 10. So this is a +1. So I'm going to go on the y-axis, +1. I'm going to go slope equals 2. I'm going to go rise 2, run 1. Up 2, right 1. Do we hit any intersection points that are looking the same? So, did we hit where we wanted to? 3, 7 is where I wanted to intersect. And I wanted to also intersect at -1, -1. Okay, graphing a system of inequalities. Okay, first equation, I'm going to do some algebra. I need y equals mx plus b as my idea. Obviously not an equal sign, but I need the y alone, I need the m and the b part. Okay, so first of all, I'm going to keep the y. I'm going to move the x, so -2x minus 9. Are we okay with that? I just moved the x. Now, algebraically, I'm going to divide everything by 3. And the 2/3 part I'm going to leave as a fraction, and then I can divide. Okay, I'm going to graph that. I know it's got a y-intercept of -3. I'm going to go down 2, right 3. And then I'm going to ask myself when I connect them, is it going to be a solid or a dashed line? So this says I'm allowed to be equal to it. So solid. Then I have to pick the side that's greater, so I have to think about which direction would I be angling upward. So I'm going to be going on that side of it, angling upward. Okay, next line. Have to do some algebra again. Okay, -3y is going to stay. -2x is going to, the 2x is going to move, so it's -2x. And then I need to divide by a -3. Ooh, what happens? What happens when you divide by a negative? The sign will switch. So I have to just remember that because I'm for sure 100% going to put one of those on there. So y is less than or equal to now +2/3 x and a +1. Now that's ready for me to graph because I can see the m part and the b part. So 1, then I'm going to do up to right 3. And then I do know it's a solid line. Then it says lower than, less than, angling downward. Okay, we still have one more. X is less than 7. So when you see that, you have two choices. What do you want to do, a horizontal or a vertical? What's an x equals line when you graph them? Vertical line at 7, and it is dashed. Because I can't be equal to it, it just says less than, so not equal to it. Then I have to be less, so I have to go left of it. And then I'm picking where to shade that's going to work for all three things. And that was the zone. And you can check your answer by taking a coordinate. For instance, 4, 0 is in this zone. And then I could plug that coordinate into all three of these. And it would have to work in all three of them. Okay, last one. 1, 2, 3 equations we're going to solve for. Okay, somebody needs to pick a variable to get rid of. I don't think it matters. There's maybe not one that's particularly easier than the other one. The x's, the y's, or the z's. What do we want to attack here? Z. Okay, I'm going to go equation 1 and 2. One and 2 I'm going to put together. We're attacking the z's. Okay, when you're doing this on your test, just stop and make sure that you copied them down right, because I just had my grade 12 calculus class do this test on something obviously different than this, but same idea. And that was some errors that they were making even. Okay, what do you want to do to get that out? Add or subtract them? Subtract. Okay, -2, subtract 3. Two subtract a -2. Double negative means add it. And again, I'm going to subtract a negative. So double negative adds 5. So that's my fourth equation now. Okay, next. We're going to get Z. What do you want to do? We could do 1, 3 or 2, 3 together. Doesn't matter. Should I just go 1 and 3? But what am I going to need to do with equation 1? I'm going to have to times it by 2 to match it up with this 2Z. Does that make sense? Do you see that? I got to get this the same. So I'm going to double the first equation. So this is my setup. So make sure you double everything. Okay, especially when you have to do a multiplier, go back, double check. Did I multiply everything? I often get people who multiply this and then forget to do the rest or something like that. Okay, we decided Z's is the attack. So add or subtract. I'm going to add. Okay. Negative 5x plus 5y equals 20. Okay, FYI, if you were doing this on your own, there's a bunch of different ways you could have done it, right? Okay, I'm putting 4 and 5 together. Looking at the variables now, guess what? I think I like to get rid of the x's because they're already set up. Sometimes here you might have to multiply, but so that's nice that they set up already. So I'm getting rid of x's on those, so I'm going to have to subtract. If they look the same, you got to subtract them. S and S, if they're the same, subtract. 4 subtract 5, negative 1y. 19 subtract 20, so y equals positive 1, because we got to divide there. Okay, work your way back up the page. So we're going to plug in. Where's our next spot to plug in? Give me an equation number. 1, 2, 3, 4, or 5. Okay, your options are 4 or 5 because you're going up the page. So it doesn't matter, whatever one looks maybe easier to you, but it really doesn't matter. I'm just going to go with 5. So negative 5x plus 5y, replace with a 1. Okay, so do some algebra, minus the 5 to the other side. Negative 3. Valley, you look like you went ahead. So far matching?
No, I finished and I have horribly large numbers.
Oh, so not these ones.
No.
Okay, and I'm going to go back up the page to do more plugging in. So now my options are doing a 1, 2, or 3, and I'm just going to say which one maybe looks like the easier math. I don't know, nothing really stands out. Should I just pick 1? So I picked equation 1. And you can always check your answers when you're done by taking those three numbers and plugging them into, now if I go into equation 2 or 3, they should work in those equations as well.